In this video, I will be talking about the 11 steps of the sliding filament theory and how we're able to contract our muscles the way we do to be able to pick up pencils, cups, computers, and everything we can pick up around our houses. So without further ado, let's get straight to it. So the first step of the sliding filament theory is that the brain has to originate a message and be released from the central nervous system, specifically at the elbow flexor of the control center of the brain. This needs to happen for the process to begin. As you can see, all those little lines are signals that the brain is originating for the process to begin. Once the message is done originating and then is released from the central nervous system, the message will then travel down to the spinal cord and branch off at shoulder level and travel down the PNS, also known as the peripheral nervous system. This needs to happen for the next step to occur. Then the message will continue traveling down the axon branch towards the axon terminal to the NMJ, also known as the neuromuscular junction. Only a few muscle fibers will be recruited depending on the weight of the object that you are lifting. In step 4, the message is carried through the axon terminal via the ACH to the sarcolemma. Attached to the sarcolemma are receptors that will then take the ACH down to all the muscle fibers involved. In step 5, the ACH causes the sarcoplasmic reticulum to release calcium ions from the terminal cisterna. The calcium ions then find their way to the attachment sites on troponin, which are located on the actin's tropomyosin. The tropomyosin swivels, causing the binding sites for the myosin on the actin filament to be exposed. The myosin heads then attach themselves to the binding sites on the actin. ATP is broken down by ATPase, causing the power stroke and the sliding of actin along the myosin filament. Contraction of the filaments will continue until you decide to stop the activation of the biceps bronchi muscle. As long as calcium is present, contraction will continue. Once you decide to stop the activation, calcium will be removed into the sarcoplasmic reticulum. Troponin and tropomyosin will once again cover the binding sites of the myosin of the actin filament, and the muscle will return to its resting state.